Okay, so this is going to begin our study on Chapter 1, which is all about methods of data collection. Now, in this chapter, we're largely going to be just getting a feel of what statistics is and some terminology that we're going to be doing. So it is very vocabulary intensive. Let me know if you guys have any questions on it. It really is just a giant definition chase where you just have to get to know a lot of terms in this chapter. So without further ado, section 1.1, which is the introduction to the practice of statistics. So, first and foremost, what is statistics? Well, statistics is the science of collecting, organizing, summarizing, and analyzing information to draw conclusions or answer questions. So, we really want to be thinking about statistics as a science that provides some measure of confidence in any conclusions, typically numerical conclusions. And by the way, by information, we mean data. So we're going to want to know something about a general population, and without just trying to intuitively say what we think, we want to put a science behind why we know certain things. And that's why we use statistics in every single science and business decision that's out there. It provides you evidence towards that conclusion. Now, I used a couple words right there that we should really define, the first being population. When I say population in statistics, I mean something very specific. The population refers to the entire group being studied, whereas a sample will end up being a subset of that population. For instance, if I was wanting to know something about the state of Texas, and I just picked, let's say, 1,000 random adult Texans, the state of Texas, the people in it anyway, would be my population, and the 1,000 Texans that I picked would be my sample. It's a subset of that giant population. As another example, let's say 50 freshmen are selected to participate in a study. Turns out the freshman class would be the population that we would be studying. Maybe we'd want to know what the average GPA of all freshmen was. And our sample, the 50 freshmen, would be that subgroup or subset of the population. If you just listed every single individual along with the characteristic in the thing you're studying, you'd be doing a census. So a census is a list of all individuals in a population along with certain characteristics of each individual. Now, you would want to do a census if you just wanted the exact answer. So, for instance, if I wanted to know what every voting age adult in America, who they were voting for in 2024, say, well, one way I could do it is I could just ask everybody and then bam, I have my answer. Well, turns out that census is very expensive, be it time or money, to gather. So that's why we typically go to a sample. It's a little bit cheaper. Now, since we will be wanting to know information about a population, but we'll be gathering that information through the use of samples, let's talk about numerical summaries of them. A statistic will be a numerical summary of a sample, whereas a parameter will be a numerical summary of a population. Think that the S's line up, sample, statistic, whereas the P's also line up, population, parameter. Now, it's important that both a statistic and a parameter are numbers. These guys can look kind of similar, so the important distinction is what does the number represent? The entire group or some small subset of that group? As two examples, suppose 48.2% of all students on campus own a car. Is this a parameter or a statistic? In this case, we would actually say that this is a parameter. The reason we would say parameter is because we're studying all students. So we're not taking a random sample in this case. Next example, in a phone survey of 100 random homes in a country, 21% of families had garages. Statistic or parameter? In this case, we would say statistic. The specific 100 random homes in that country make up the sample. The population we'd be studying would be homes in that country, just all homes. Now, this leads us to two more definitions, and this is kind of coming from how we will be doing statistics, so more on that in a bit. The first would be descriptive statistics, which will just consist of organizing and summarizing data. So, as I say here, it describes data through numerical summaries, tables, and graphs. So, these are just stats that describe something. And they're stats that you typically just gather. Now, this is going to be opposed with inferential statistics. So descriptive statistics is typically what you think of. However, inferential statistics, think to infer something, will be very helpful when I want to extend my stats I gathered at the sample level to the population level. So inferential statistics uses methods that take a result from a sample, extend it to the population, and measure the reliability of the result. It's important that we measure the reliability because just because a sample says something might not mean the population agrees. For instance, if I picked on all the kids with, say, rich parents and they all had these crazy nice cars, let's say, on that earlier example, that might not be representative of the typical car owned by a high school freshman. Now, when we're doing statistics, we will be after certain qualities or variables. And in fact, you could be after quantities as well, as we'll see. A variable is just going to be a characteristic of the individuals within the population that you are looking to study. Now, these variables come in two forms. They can be qualitative, meaning you can classify them on some attribute or characteristic, qualitative quality, or they could be quantitative variables, meaning they are numbers. So if you have a number, it's a quantitative variable. If you have non-number, we'll say qualitative. For instance, hair color would be a qualitative variable. So for instance, are the following qualitative or quantitative? Well, it turns out hair color is completely qualitative. There's no number involved. Amount of disk space in gigabytes, on the other hand, will be quantitative. It is completely a number in gigabytes, like 128 gigs. Now, when you are in the realm of quantitative variables, so we are talking about when you're dealing with a number, there are two types of variables that you can talk about with quantitative. The first would be discrete variables. Now, I'll read the definition, then I'll give us the intuition. Discrete variable is a quantitative variable that has either a finite number of possible values or a countable number of possible values. What this means is that you're dealing with a variable that can't take on every single number. So as I say right here, discrete variables cannot take on any value between any other two values. Something that might be useful to think of here would be, say, shoe size. You could be size 6, you could be 6.5, 7, all the sort, but you can't take on every single value between 6 and 6.5. I don't know of anybody that has a 6 and an 8 shoe size, for instance. Now, what if you can take on every single value in between? Well, this is what we're going to call a continuous variable. So a continuous variable is a quantitative variable, number, that has an infinite number of possible cases and it's not countable. By the way, that word countable just means you can kind of line up the options with your counting hands. Now, the important trait here is that it can take on any value between any other two values. For instance, if we want to talk about weight, I could weigh 216 pounds, I could weigh 217 pounds. Could I weigh 216 and a half? Yeah. Could I weigh between 216 and 216 and a half? Well, yeah, for sure. I could take on any number in between that. I know that there might be some measurement troubles there, but theoretically you could take on any number between that. That's the difference between discrete and continuous. As a couple of examples, let's consider the following. The number of students in a class. Well, I could have no students in my class. 1, 2, 3, and all the sort, but I can't have, say, 2.5. We don't count people by halves. So in this case, number of students will absolutely be discrete. Now, heights, on the other hand, are actually going to be continuous. So theoretically, I could be any number between, say, 5, 6, and 5, 7. I could be 5 feet and 6.001023 inches. So height would be continuous, just like weight. What about hair color? Well, this is actually a trick question. Remember that when we're dealing with discrete versus continuous, we are dealing with quantitative variables. So in this case, the answer is neither of them. We are going to be qualitative for that variable. Now, instead of just going via qualitative and quantitative, which once you get used to it, it's pretty easy to know the difference. Discrete versus continuous maybe is a little bit more difficult. You might want to categorize variables by level of measurement. So instead of classifying a variable as qualitative or quantitative, we often assign a level of measurement to that variable instead. Now, here's your levels of measurement, going from least difficult to attain, kind of the easiest to get, up to most difficult to attain. You've kind of ascended to the highest category if you make it to ratio. Well, starting off at the lowest, you have the nominal level of measurement. Then you get the ordinal level of measurement. Then you get the interval level of measurement. And you end at the ratio level of measurement. To visualize this, we kind of have combined this to a nice little graphic. It's very similar to the hierarchy of needs, where you can't go up a step until you've had all of your bottom steps fulfilled. So let's talk about the lowest step, the nominal level. At the nominal level, attributes are only named. You can only determine the name of the variable you're after. For instance, hair color. That would be pink, red, blue, what have you. That's the nominal level. This leads us to the ordinal level. So if you're at the ordinal level, you've already attained the nominal level. You can already be named. However, at the ordinal level, you can also be ordered in some meaningful way. So let's consider letter grades for an example. Letter grades, A, B, C, D, F. Can you name them? Well, yeah, I just did, right? Okay, can you order them in a meaningful way? Yeah, I can go from highest to lowest or from lowest to highest. So they would achieve the ordinal level of measurement. Above the ordinal level would be the interval level. So at the interval level, you can be named, you're nominal, and you can also be ordered. But at the interval level, it turns out distance between two measurements has a meaning. So in this case, we should consider something like temperature. Can you name all of the temperatures in degrees Fahrenheit? Yeah, you just write them down. They're all numbers. Can you order all of the temperatures in degrees Fahrenheit? Yeah, hottest to coldest or coldest to hottest. Can I say something along the lines of 70 degrees is 20 degrees cooler than 90 degrees? Yeah. So it turns out me doing something like 90 degrees take away 70 degrees, this 20 degrees has a little bit of meaning, that difference in degrees. This is opposed to, say, our letter grade example, A through F, because me achieving a grade of an A minus a C, this does not make any sense. That's never going to show up on your scorecard. The highest level of measurement will be the ratio level of measurement. At the ratio level, you can be named, you can be ordered. Distance between any two measurements is a meaningful thing, like 20 degrees, but it turns out a zero means the absence of a quantity. So there is a zero, and the zero actually matters a little bit. Let's think about Fahrenheit. If I have 0 degrees Fahrenheit. Does that mean that there are 0 temperatures outside? Well, no, there's still movement in the particle, so there's still something out there. We just call it 0. I wouldn't call that a meaningful 0. Maybe instead, to give us an example of the ratio level, let's consider the number or the amount of time that you have studied in the last week. Well, can I name it? Yeah, you could say, I don't know, 2 hours, 3 hours, 26 hours. So it can be named. Can you order it? Well, yeah, let's order it from most amount of time studying to least. Is the distance meaningful? Yeah, if you studied for 48 hours and your friend studied for 24 hours, you studied a day longer, so distance is meaningful. Last but not least, does a 0 mean the absence of a quantity? Well, yeah, if you studied 0 hours, there was no studying done. The amount of studying is just absent. That makes you achieve the ratio level. But you could only achieve one of the higher levels if you've achieved everything below it. Now, I know I said a lot of things right there with one graphic, but I think the graphic is very helpful. If you didn't quite catch everything, you can find it right on the slide, so I would say pause it right here if you do want to go over that. Let's do some examples. Determine the level of measurement. Always start at the bottom. Let's start with gender. Can it be named? Well, yeah, right? You can definitely name all the genders out there. Okay, can it be ordered? Well, missing any context, no, right? There's no meaningful way to just order gender on its own in the middle of space. So gender, we would say, achieves, apologies, that's a horrible end, the nominal level of measurement. How about temperature? In degrees Fahrenheit. Well, okay, we can name all the temperatures in degrees Fahrenheit. We can order it from hottest to coldest or vice versa. And the difference matters. So, for instance, 160 degrees Fahrenheit is 80 degrees hotter than, say, 80 degrees Fahrenheit. But notice when we're talking Fahrenheit, 0 degrees Fahrenheit doesn't mean the absence of temperature. Therefore, we would achieve the interval level here. By the way, for you science nerds out there, if you were talking in Kelvin, where 0 is called absolute 0, it means there's no particle movement, Kelvin would achieve the ratio level. I digress, let's continue. The number of days during the past week that a college student studied, yeah, you can name it. Yes, you order matters from most amount to least amount. Hey, difference matters. So I already kind of talked about this example. And also, there is an absence of studying if you have 0 hours studied. So we would say that this is the ratio level. And as you can probably guess, since we've already done it, letter grade would be at the ordinal level. I can name it, I can order it, but I cannot talk about differences in a meaningful fashion. You can't get an A minus a D for a grade. And by the way, here is a little bit of reasoning behind all those answers, just in case you needed it. Now, to conclude the section, I want to talk about how we're going to do statistics. Remember, statistics is just all about getting meaningful information about some population that you want to study. So, in order to do statistics, we must do the following. First off, identify a research objective. Hey, what do you want to know and about who do you want to know it? So it could be voting age population in America, and I want to know who you're going to vote for next election. It could be kindergartners in a class, and you want to know what their favorite lunch is. Whatever it may be, get that population and that research objective. Step two, collect data needed to answer the question posed. You could do either a census if your population's small enough and it's cheap enough, or you might have to gather a sample and try to do and collect data from them. Once you have collected the data, You're going to describe the data, maybe get a percent or something like that, get some number. And then last but not least, from that data, you will perform an inference to gather information about the population. In the case of doing a census, there's no inference needed. You just have the information available. However, if you took a sample and know the information about the sample, you know the statistic, then you will perform an inference to try to get at what the parameter is for the population. Here's a visualization. We start with our population, we gather a sample from that, and we will talk about how you gather this sample. Once you're at the sample level, you do your test or whatever have you, and then ultimately we'll use the information found down here to tell us about something back at the population level. Now, just so you can see what a typical question will look like, a news service conducted a survey of 1,059 adults aged 18 years or older in a certain country, and it was conducted August 31st through September 2nd, 2015. The respondents were asked, of every tax dollar that goes to the federal government, how many cents of each dollar would you say are wasted? The four possible responses, because you can't just leave it open-ended, the four possible responses are that the federal government wastes less than 10 cents per every dollar, between 11 and 25 cents per every dollar, between 26 and 50 cents per every dollar, and last but not least, 51 cents or more per dollar. Of the 1,059 individuals surveyed, 38% indicated that 51 cents or more are wasted per dollar. The news service, having done their little survey, reported that 38% of all adults in the country, 18 years or older, believe the federal government wastes at least 51 cents or more per dollar on tax revenue. With a margin of error, by the way, of 4% and a 95% level of confidence. By the way, notice that we started with a statistic because it related to our sample. And then we ended up guessing at a parameter which related to the population of all adults in the country. Now, we did tack on a little bit of a, kind of a safety net for ourselves by saying, hey, I could be off by 4%. Could be between 34 and 42%. Margin of error, 4%. That's what that means. And by the way, I'm also just 95% confident, like pretty dang confident, but I might be a little wrong. Who knows? Questions. What is the research objective? What is the population? What is the sample? What are the descriptive statistics? What can be inferred from the survey? Feel free to go back to the slide, read through it, and try to answer the questions. At this moment, I'll fast forward. Let's talk about it. Turns out the research objective was to determine the percent of adults in the country who believe the federal government wastes 51 cents or more of every dollar. Notice that we kind of get this research objective once we see how they reported it. If you just looked at the survey, you might say, hey, to figure out what percent of adults believe what percent of the dollar is wasted. Notice that's a little bit vague. Really, we want to be very specific and say what percent of adults in the country believe that 51 or more are wasted per dollar. Therefore, the population was adults in the country aged 18 years or older. This leads us to the sample. The sample was the specific 1,059 adults in the country that were surveyed. The descriptive statistics, the ones we actually got our hand on, were the 38% of individuals surveyed, indicating that 51 cents or more are wasted. So 38% from the sample is our descriptive statistic, leaving behind the inferential survey, our inferential statistics. So what can be inferred? The news service is 95% confident that the percentage of all adults in the country who believe the federal government wastes 51 or more cents per dollar received is between 34 and 42%, with a 95% level of confidence. Now you can see right here I got those numbers by doing 38 plus or minus my margin of error. But this is ultimately going to be what we can gather from that type of question. Next time we'll be talking about section 1.2. In the meantime, let me know if you have any questions. Work on those levels of measurement. That will be the main thing that is on the exam, besides like qualitative versus quantitative, discrete versus continuous. Levels of measurement makes up the other portion. But other than that, best of luck to you. Have a great day.